Today we are going to learn about mastering transformer models for sentiment analysis. By the end of this video, you'll understand how to implement and fine-tune transformer models like BERT to perform sentiment analysis with high accuracy.
Welcome to our session on mastering transformer models for sentiment analysis. Transformer models have revolutionized the field of natural language processing, particularly in understanding context and sentiment with remarkable accuracy. These models, through their ability to process and understand large volumes of text efficiently, have become indispensable in various applications ranging from chatbots to sentiment analysis. In this session, we'll dive deep into the mechanics of transformer models, with a strong focus on BERT, and explore how you can leverage these tools to perform sentiment analysis with precision and ease.
Transformers are composed of an encoder-decoder architecture that allows them to handle input sequences efficiently. The key innovation in transformers is the self-attention mechanism, which enables the model to weigh the significance of different words in a sentence relative to each other. This mechanism helps in capturing long-range dependencies in text, which traditional models struggled with. The encoder reads the input text and creates a set of attention vectors, while the decoder generates the output by processing these vectors. Transformers excel at parallelization, allowing them to process large datasets much faster than previous models. This architecture is particularly effective for tasks like sentiment analysis, where understanding the context of words is crucial. Transformers are particularly well suited for sentiment analysis due to their ability to understand context deeply. Unlike traditional models that might consider words in isolation, transformers analyze the surrounding context of each word to determine sentiment polarity. This is crucial in detecting nuances like sarcasm or mixed sentiments within a sentence. Additionally, transformers can handle complex sentence structures and multiple languages with ease, making them versatile tools for global applications. Their high accuracy in prediction stems from their ability to model long-range dependencies and understand the intricate relationships between words, which are pivotal in sentiment analysis.
BERT, which stands for bidirectional encoder representations from transformers, is a groundbreaking model developed by Google. It introduced the concept of bidirectional training of transformers, allowing it to consider the context from both directions in a sentence. BERT is pre-trained on a large corpus of text using two unsupervised tasks: masked language modeling, where some words in the input are masked and the model has to predict them, and next sentence prediction, where the model predicts if two sentences follow each other. After pre-training, BERT can be fine-tuned for various downstream tasks, including sentiment analysis, by adding just a small number of task-specific parameters.
BERT's ability to understand context and semantics has made it a powerful tool for sentiment analysis. In real-world applications, BERT can classify sentiment with high accuracy, even in cases where the sentiment might be ambiguous or mixed. This is a significant improvement over traditional models, which often struggle with such complexities. BERT's architecture allows it to scale efficiently, making it suitable for processing large datasets commonly encountered in social media sentiment analysis, customer feedback, and market research. Its adaptability across different domains and languages further enhances its utility in sentiment analysis, allowing businesses to gain insights from diverse and multilingual data sources. Before feeding text data into a transformer model like BERT, it is crucial to pre-process it correctly. This involves tokenization, where text is split into tokens that the model can understand. BERT uses a word piece tokenizer, which efficiently handles vocabulary and out-of-vocabulary words by breaking them into subword units. Special tokens such as CLS and SEP are added to denote the start and separation of sentences. Handling imbalanced data through techniques like oversampling or using weighted losses can improve model performance. Text normalization, including lowercasing, removing special characters, and correcting misspellings, is also essential to ensure data consistency and quality. Fine-tuning BERT for sentiment classification involves customizing the model to learn from your specific dataset. Begin by setting up your environment with the necessary libraries, such as TensorFlow or PyTorch. Load pre-trained BERT weights to leverage its existing knowledge. Adjust the learning rate and batch size. These hyperparameters are crucial for stable training. Typically, a lower learning rate is preferred to prevent the model from forgetting what it learned during pre-training. The final step involves adding a classification layer on top of BERT, which the model will use to predict sentiment classes. This layer is trained using your labeled data, allowing BERT to specialize in sentiment classification. Once the model is trained, evaluating its performance is crucial to ensure it meets the desired accuracy and reliability. Common metrics for sentiment analysis include precision, recall, and F1 score, which provide a comprehensive view of the model's performance beyond mere accuracy. A confusion matrix can help visualize the model's predictions against true labels, identifying areas where the model might be misclassifying sentiments. Cross-validation techniques ensure that the model's performance is consistent across different subsets of the data, reducing the risk of overfitting. Regularization techniques and dropout layers can further help address overfitting, ensuring that the model generalizes well to unseen data. Working with transformer models can present several challenges, particularly when dealing with large datasets or limited computational resources. Data sparsity can be addressed by augmenting the dataset or using techniques like transfer learning. Computational limitations may require optimizing your model's architecture or using cloud-based resources for training. Noisy data, common in real-world datasets, can be cleaned through pre-processing and normalization. Hyperparameter tuning, though time-consuming, is essential for optimizing model performance. Lastly, interpreting model outputs can be challenging, as transformers are often seen as black boxes. Techniques like attention visualization can help understand how the model makes predictions, offering insights into its decision-making process.
The practical applications of transformer models like BERT in sentiment analysis are vast and impactful. In social media, sentiment analysis helps businesses and organizations monitor public sentiment and trends, allowing them to respond quickly to public opinion changes. Analyzing customer feedback using sentiment analysis provides insights into customer satisfaction and areas for improvement. Market researchers use sentiment analysis to gauge consumer sentiment towards products and competitors, informing strategic decisions. Brand reputation management is another critical application, where sentiment analysis helps track brand perception and manage crises. A case study of BERT in action might involve its deployment in a company to analyze customer reviews, leading to improved customer satisfaction and product development. In conclusion, transformer models like BERT have transformed the landscape of sentiment analysis, offering unparalleled accuracy and contextual understanding. We've explored the architecture of transformers, their application in sentiment analysis, and how to implement and fine-tune these powerful models. As these models continue to evolve, their potential applications will only expand, providing even more opportunities to harness the power of AI in understanding human emotions and opinions. We encourage you to continue exploring the fascinating world of transformer models and discover new ways to apply them in your projects.